In our previous lesson, we started with what probability is and how to find probability as a fraction. And you have been asked in your previous assignment whether probability is written only as a fraction. Now, probability can be written as a fraction, as a decimal, and as a percentage. In today's session, we will explain how to write the probability, not only as a fraction, but also as a decimal and as a percentage. So 10 cards numbered 1 to 10, and then one card is drawn. Find the probability of each event. We are going to write the answer in or as a fraction, as a decimal, and as a percent. When you have such a question, the first thing you have to is model it or draw or sketch a diagram that represents the 10 cards. We need the probability of card number 8. Remember when I told you step number 1 is always write the total in front of you. So the total here is the total number of cards. We have 10 cards. Now the probability as a fraction is how many number 8 cards do we have? We only have one card numbered 8. Then when we need to write the probability as a fraction, the denominator is always the total, which is 10, and the numerator is how many cards do we have? We have only one card numbered 8. So our fraction is 1 out of 10. We look for possibility for simplification. Here we cannot simplify it more. Then the probability of card 8, of drawing card number 8, is 1 out of 10. It is written as a fraction, but remember in the question they need us to write it as a decimal and as a percent. Let's start with writing it as a decimal. To write it as a decimal, it's simply dividing the numerator by the denominator. So the probability of 8 is 1 divided by 10. If you use your calculators, the answer as a decimal is 0.1. As well, they need us to write it as a percent. To write it as a percent, it is easy. The probability of 8 as a percent, you take your decimal, the number that you obtained as a decimal, and you multiply it by 100. So it is 0.1 multiplied by 100. The answer will be 10%. So as you can see here, the probability, we wrote it as a fraction, we wrote it as a decimal, and we wrote it as a percent. There is an important note here. When you write your probability as a decimal, the decimal number is always less than 1. You can never get a probability that is 1.2. You can get a probability which is 1 or less. That means the probability as a decimal should be between 0 and 1. It can never be 1.2, 1.3, never. As well as a percent, your maximum percentage would be 100. Your minimum is 0. I cannot get a probability which is 110%. Or a probability, for example, that is 120%. Keep that in mind. So if you got a probability as a decimal more than 1, this means that you have something wrong. Or if you got the probability as a percent more than 100, this means you have something wrong and you need to double check your answer. Another example, find the probability of odd numbers. What's the probability when you draw a card? It would be odd. We all know that the odd numbers are 1, 3, 5, 7, and 9. So let's count how many odd cards do we have. We have 1, another card, a third card, a fourth card, and a fifth card. So we have 5 odd cards. Then the probability is written as a fraction first. The total is 10, denominator is 10, and we got 5 odd cards. If there's a possibility of simplification, we do it. We can simplify more, divide by 5, and that's a 1 out of 2 as a fraction. Now let's write it as well as a decimal. If I need to write it as a decimal, we have to divide the numerator by the denominator. So it's going to be 1 divided by 2. If you use your calculators, the answer will be 0.5. As a percent, you multiply the 0.5 by 100, and that is, as well, using your calculators, we have 50%. Another example, find the probability of drawing a card numbered 1, 2, or 5. Remember when we explained this in our previous session, when we have or, this means we are going to count the cards that are numbered 1, cards numbered 2, and cards numbered 5. Now, to write the probability, we write it as a fraction first. The denominator is 10, which is the total. And then we have one card numbered 1, one card numbered 2, and one card number 5. So this is a total of 3 cards. Then it's a 3 out of 10. If we want to write it as a decimal directly next to it, it's a 3 divided by 10. It's a 0.3. If I want to write it as a percent, remember we multiply the 0.3 by 100, which is 30%. We need to find the probability of drawing a card that is less and getting a number that is less than 5. To write a probability, it's a fraction. Our total is 10. Now let's count the number of cards that are less than 5. Remember, less than 5 means 5 is not included. We have card number 1 is less than 5, card number 2 is less than 5, card number 3 is less than 5, and card number 4 is less than 5. So we have 4 cards that are less than 5, so it's 4 out of 10. Again, we check if there is a possibility of simplifying. That's right, divide by 2, and that's a 2 out of 5 as a fraction. If I want to write it as a decimal, I divide the 2 divided by 5, and that's an answer of 0.4. If I want it as a percent, I multiply the 0.4 by 100 and I will get an answer of 40%. Probability of taking a card that is greater than 3. So we are going to write it as a fraction, and the denominator is the total, which is 10. It does not change. And then we count how many cards are greater than 3. Remember, greater than 3, this means that 3 is not included. We have 1, 2, 3, 4, 5, 6, 7. So we have 7 cards that are greater than 3. 7 out of 10. We check for any possibility of simplification. We don't have. Then we have to write it as a decimal. This means 7 divided by 10, and that's 0.7. Then we have to write it as percentage. And how do we do it? 0.7 times 100, that's a 70%. To summarize it, to change from a fraction to a decimal, the probability, you have to divide the numerator divided by the denominator, and then you're going to get your decimal. Then you multiply your decimal by a 100, and you are going to get your percent. Another example, Joel has a bowl of colored candles shown in the table. Now, they need us to find, as the first example, the probability of taking from the bowl a candle that is red. As we said, step number 1 is finding your total. Here the total is not given. How do we get the total? By adding how many candles do we have. So we have to add 5 plus 3 plus 1 plus 6 to give us a total of 15 candles. So let's keep this at the top, since we are always going to refer to this total. So we have a total of 15 candles. Probability of red. Probability of red is a fraction where the denominator is our total and our numerator is how many red candles do we have. Based on the table, we have 5 red candles. So it is 5 divided by 15. If there is a chance of simplification, we have to do it. Divide by 5, divide by 5, and that's 1 out of 3 as a fraction. If we need to write it as a decimal, 1 divided by 3 is 0.3. We take three numbers after the decimal point. If we need to write it as a percentage, multiply it by 100. That's 33.3%. Now the probability of yellow or green. We have or. This means we are going to take them together, count them together. We have one yellow candle and 6 green candles, and this will give us a total of 7, of course, out of 15. We cannot simplify it, it's in its simplest form. We change it now into a decimal, and that's 7 divided by 15, three numbers after the decimal point, 0.467, and then as a percent we multiply it by 100, and that's a 46.7%. Probability of getting an orange candle. The orange is 3 out of 15. We can simplify it more. Divided by 3, we will have 1 out of 5. This is as a fraction. If I need to write it as a decimal, I divide 1 divided by 5, it's 0.2. As a percent, we multiply 0.2 by 100 to get 20%. Now I need the probability of, and pay attention to this, not orange. What do we mean by not orange? This means I need the probability of getting any candle color other than orange. What does that mean? Do I count orange? I do not count the orange. I count all the other candles and I skip the orange because I need any candle that is not orange. This means I have to get 5 plus 1 plus 6, and that's a total of 12. So it's a 12 divided by 15. We simplify it more, divided by 3, divide by 3, and that's a 4 out of 5 as a fraction. If I need to write it as a decimal, it is 4 divided by 5, which is 0.8. If I need to write it as a percent, multiply it by 100, it's 80%. If you focus here on the last two probabilities, I've got the probability of orange and the probability of not orange. Orange and not orange. If you notice here, they are like opposite to each other. I need the orange and the not orange, but in mathematics we don't call them opposite. We call them that those two events are complementary events. Other examples of complementary events could be the probability of odd and the probability of even, because numbers could either be odd or even. Those are also complementary events. In letters, the probability of consonants and probability of vowels, because letters could be either vowels or consonants. Those are complementary events. There is one more note about complementary events. For example, we got that the probability of orange is 0.2 as a decimal, or 20%, and the probability of not orange was 0.8 or 80% as a percent. We agreed those two are complementary events. Now, always in mathematics, if you add the probability of any event plus the probability of its complementary, you are going to get a 1 if they are written as a decimal, or 100%. Let's verify it based on the examples that are given. The event is orange, so the probability of orange is 0.2. Its complementary is not orange, and that is 0.8. If you add them, you're going to get a 1. So those two events are complementary. Let's try it with percentage. 20% plus 80, and that's 100. So they are definitely complementary events. Other examples on complementary events could be probability of red and probability of not red, or the probability of yellow and probability not yellow. As we said, probability of odd, probability of even, because numbers can be either odd or even, probability of vowels, probability of consonants, because the letters could be either vowels or consonants. So those are complementary events. Aim of this session as well is not only to calculate probability in decimal, fraction, and percent, but also to show you that you might be asked to calculate probability from any visual display. It could be in the form of a table, cards, colors, a spinner, or, for example, this graph. They want, let's say the example is find the probability of R and B. Here we have different types of music, and they want us to find the probability of picking a song that is an R&B music. Step number 1 is finding your total, and the total here is adding all the number of songs. So I'm gonna add 10 plus 25 plus 12 plus 3 to get a total of 50 songs. Now the probability of R&B is going to be equal to a fraction where the denominator is 50 and you've got the numerator as 12. If we have a possibility of simplifying, we simplify. We can divide by 2 to get a fraction of 6 out of 25, and it is as a decimal 0.24 and as a percentage 24%. Now what if I wrote probability of not R and B? Remember, we have not here. So these two are considered to be complementary events. To find the probability, it's out of 50. This means we have to add all the types of music that are not R&B. That means it is 10 plus 25 plus 3, and that's a 38 out of 50. If we have a possibility of simplifying, we simplify, divide by 2, and that's a 19 out of 25. If we as a decimal, it is 0.76 and it is 76% as a percentage. Now, in order to make sure and verify that they are complementary, remember, if we added the percentages, we are going to get 100%. Let's try it in order to verify that they are complementary. So we have 76 plus 24, it is 100%. So this verifies for us more that they are complementary. Let's try the decimal. The decimal we have 0.24 plus 0.76, that's a 1 as well. This verifies that those two are complementary events.